we're going to focus in on what we see as an innermost function. In this case, it's our x squared plus 1. That gets us right into our steps, and step 1 is to choose u, so we're going to let u equal x squared plus 1. Our next step is to find du, and du is going to be the rest of this integrand, the x and the dx. Let's go ahead and take du now. So as I take the derivative of u on both sides, the derivative of x squared is 2x, the derivative of 1 is 0, but I'm going to follow that with a dx. Now what I've got circled up there though is an x dx, so to get that isolated, I'm going to divide off that 2, and I've got 1/2 du to replace the x and the dx. But we still have 2 more pieces in this integral that are in terms of x, and those are our limits. So we're going to use our u definition to replace those limits, the 1 and the 0. So let's go ahead and do that. I'm going to write my limits up here. Now these are my x limits. To replace them in terms of u, I'm going to use my u formula, which is that x squared plus 1. So I'm going to compute u using 1 as my x value. So that's going to be x squared plus 1. 1 squared plus 1 gives me a 2. So my upper limit for my u sub is going to be a 2. Let's do the very same thing with that lower limit. We're going to do u of 0, again using u's formula, x squared plus 1. It's going to be 0 squared plus 1, and I get a lower limit of 1. Now I'm ready to do that full u substitution. So I'm going to rewrite my original integral in terms of x, but I'm going to switch the order around just a little bit so it's easier to follow along with my substitutions. So as I do my substitutions, now everything's going to be in terms of u. Starting with those limits of integration, they now go from 1 to 2. Then I've got my e. But I know that x squared plus 1 is my u, so my u goes there, and replacing my x dx is my 1/2 du, so times 1/2 du. I end up with a pretty nice integral. Let's go ahead and simplify this guy and work it through. I'm going to pull that 1/2 out in front, so I get the integral from 1 to 2 of e to the u du. My very favorite integral to take, because I'm just going to get my e to the u back. So I get 1/2 e to the u, but I do need to evaluate that for u's running from 1 to 2. So applying that fundamental theorem of calculus part 2, I need to do f of 2 inside those parentheses minus f of 1. Here's what that looks like. I've got the 1/2 still on the outside, but inside those parentheses, I've got e to the 2 minus e to the 1. And we can write this, I'm just going to use the exact form, e squared minus e, all divided by 2. Here comes our second example. Now here's our second example. I really want you to be thinking about that innermost layer. What do we want to let u be? Let's go ahead and bring up those same 3 steps, starting with choosing u. That innermost layer, did you choose the natural log of x? Because that's exactly what we need here. So u is equal to the natural log of x. Step number 2, I'm going to take that derivative and I'm working to take care of what's left here, the 1 over x and the dx. As I take that derivative, I get du on the left, and the derivative of the natural log of x is 1 over x, and I'm going to follow that with a dx. Now finally, we've got to replace those limits of integration. So my limits of integration were running from 1 to e squared, but these were in terms of x. I need to use my u definition to get them in terms of u instead. So I'm going to take u of e squared. That's going to be the natural log of e squared, but the natural log and e are inverse functions of each other, and I end up with a 2 as my upper limit in terms of u. Let's do the same thing to 1. Okay, so for that lower limit, I need to put 1 into my u formula, and that's going to be the natural log of 1, but the natural log of 1 is equal to 0, and I get that lower limit. Now I'm going to rewrite that integral in terms of x, just rearranging things a little bit. I'm going to write it as 1 over the square root of the natural log of x times, I'm just going to isolate my du stuff, 1 over x dx. Now I can go ahead and do my U substitution. Replacing those limits of integration, my brand new limits of integration in terms of U are a 0 and a 2. We let that innermost function be U. So I end up with 1 over the square root of my U. And what's left over, that 1 over x dx, is my du. So du goes here on the outside. So I've got a little bit of work to do before I'm ready to take this integral, but I am just about there. We are integrating from 0 to 2. That square root is actually a 1/2 power. So I'm going to write that as a 1/2 power du, which I can also write, so I can use my power rule, as a negative 1/2 power, bringing that u up into the numerator, and then a du. I'm ready for that power rule. I need to add a 1 to get to the new power. That's going to give me a new power of 1/2, and I need the reciprocal of that power out in front. Okay, so what does that look like? I get a 2 over 1 u to the 1/2 power, evaluated from 0 to 2. Well, this is actually 2 square root of u, evaluated from 0 to 2. Using that fundamental theorem of calculus, part 2, I need my antiderivative evaluated at 2 minus my antiderivative evaluated at 0. Let me move this 1/2 out of the way so you can see. I'm leaving that 2 out in front, but we are just about to our answer here. We end up with 2, and then I get the square root of my upper limit minus the square root of that lower limit, and my answer is a 2 radical 2. You are doing fantastic. I've got another video for you here on U-subs that are just a little bit different. Keep up the great work.